Now I'm going to go through each of the components of the Tesla coil. So first we have our high voltage transformer. In this case, this is a neon sign transformer. Neon signs require very high voltage to operate, so they use these transformers to get them that high voltage. So the way it works is it takes a low voltage from your outlet and you plug that in to the low voltage terminals here. Then, through the use of a primary coil and a secondary coil with a different number of windings, you can step up the voltage. So it takes that, it sends it through a primary coil, and then it sends it through two separate secondary coils to get 6,000 volts between this electrode and the ground. And then on the other side, you have another 6,000 volts between this electrode and the ground. But between them, there are 12,000 volts. So you have the 120 volts stepped up to 12,000 volts through the transformer, and that is sent through the safety spark gap, which is the next component. This acts to ground any high voltage spike that is created in the circuit. So what it does is all other components are connected to this before this is connected to the neon sign transformer. So it acts as a filter. It is composed of two electrodes here, which is connected to the circuit, and the high voltage sides, the neon sign transformer, and it's also has a grounded electrode. So when a high voltage spike comes through, it'll be sent through these two electrodes, it'll cross the spark gap and ground that high voltage. Then the next component we have is the main spark gap. The main spark gap is also very similar. It's connected in parallel with the safety spark gap, and these are composed of joist angles and machine screws and acorn nuts for the electrodes. They are mounted on toilet flanges, which provide a very good base. It's an excellent non-conductor, and it has good holes for mounting bolts. Connected in series with that is the capacitor. Instead of going out and buying my own capacitors, I decided to go ahead and build my own based off a very good website I found. This is a saltwater capacitor, and the way it works is it's a 5-gallon bucket filled with salt water, and then inside that salt water are 12 beer bottles also filled with salt water. So you have, with a capacitor, you have two plates where charge gathers. In this case, instead of having metal plates, you have salt water. So the salt water in the bucket that surrounds and is outside of the beer bottles is one plate of your capacitor, and the salt water inside the beer bottles is the other plate of the capacitor. And one wire connects the water outside the beer bottles, and one wire connects the water inside the beer bottles. And those are connected to these electrodes. And we have a probe here, which is just a drumstick with copper wire, and this is used to discharge the capacitor when we're finished using it. Then connected in series to that is our primary coil, which is just made out of a copper coil of copper tubing, and that is connected to a wooden board as a base with these plastic ties. And then this coil right here, this copper tubing, is a strike ring which protects the primary coil. When this toroid is giving off sparks, there's a chance that it might arc down to the copper tubing. This hopefully will take that arc and ground it. If it does not, an arc could strike the primary coil and send a high voltage spike through the circuit, and then the safety gap would need to ground that. Then we have the secondary coil, and this is composed of many turns of magnet wire. Magnet wire is just copper wire, thin copper wire, with a thin coating of enamel. And instead of most wire, which has insulation that prevents the magnetic field around it, this does not have that, so it's perfect for generating magnetic fields. Then we have the toroid, which is aluminum dry ducting, and it's based with the center of a pie pan, and then taped with aluminum sided tape. And then that is connected to the secondary with a nylon bolt, so non-conductor, to a cap on the secondary form. The way I grounded everything was, instead of using a grounding spike, I used a large sheet of chicken wire mesh that I placed underneath the circuit, and it served well to ground everything. And to make sure everything was safe, I used this probe, aptly named a Jesus stick, and all it is a plastic pole with copper wiring around it. And when we turned off the circuit, to make sure everything was safe, we took this pole with copper wiring grounded to the chicken wire, and we just touched the different components and made sure everything was safe. If it wasn't, then all the charge left in that component would be grounded, and thus making it safe. And those are the components of the Tesla coil.